Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over number 8 in part 1 of our fundamentals of calculus AB and BC. This number corresponds to number 32 of the 1969 AP Calculus multiple choice exam release test item. So let's take a look at the problem. It says if A, B, C, D, and E are real numbers and A is not equal to 0, then the polynomial equation ax to the 7th plus bx to the 5th plus cx to the 3rd plus dx plus e equals 0 has, and then we have different conditions here. So if we have a polynomial function, what do we focus in on to basically predict what the nature of the roots are going to be? What you want to focus in on is the degree of the polynomial. Okay, so the term with the highest degree tells us the degree of the um, polynomial. So this is a 7th degree polynomial. All right, so one thing that you want to note concerning the degree is that um, a polynomial cannot have more real zeros than the degree. Okay, let's write that down. A polynomial cannot have more um, complex roots than its degree. Okay, so what does this mean in the context of this problem? This polynomial cannot have more than 7 roots. Okay, so it has at most 7 roots. Now, what else can we discern from this situation? Now, the degree is 7. What kind of number is 7? 7 is an odd number. So what do we know about the least possible number of roots that an odd degree polynomial can have? If a function is odd, just like this function right here, or if you have an odd degree for your polynomial, you're always guaranteed to have at least one real root. You're guaranteed at least one real root. Okay? So how do we know that we're guaranteed at least one real root? Now the question is, what is between infinity and negative infinity? So if you have, let me just draw a number line for you. If you have a number line like this, and um, you're going continuously from negative infinity to infinity, what are you guaranteed to have hit somewhere in the center? Yeah, by the intermediate value theorem, you know for a certainty that you must cross 0. Okay, 0 is between negative infinity to infinity. So if you have a polynomial function that goes from negative infinity to infinity, you're guaranteed to have one point, at least one point, where the function assumes the value of 0, because 0 is in between negative infinity and infinity. So why are we talking about infinity, negative infinity, and 0? Well, if we look at the end behavior of this function, what we'll find out is that one end is at negative infinity and the other end is at infinity. So you're guaranteed to have at least one real root. All right. So let me go ahead and show that to you real quick. Now we have A. We do not know if A is positive or negative. So we're going to take a look at both cases. Okay. So what if A is less than 0? That's negative. What do we know about the left end behavior? What do we know about left end behavior, and what do we know about the right end behavior? We're going to take a look at both cases. Now, for A is less than 0, let me make a chart right here so our work is organized. We're going to look at the left and right end. For A is less than 0, we have a negative value for A right there. So in that situation, what does the function approach as x goes to negative infinity? All right, so at the left end, we have negative infinity. At the right end, we have infinity. Okay? So as x approaches negative infinity, this function is going to be approaching, you put a minus here, it's gonna be approaching infinity. Okay? And then on the right end, as x approaches infinity, the function is going to be approaching negative infinity. So you're going to have something like this. All right? So you're guaranteed to have something like this. Now, what if a is greater than 0? If a were positive, as x approaches negative infinity, the left end, the function is going where? It's going to be going to negative infinity, and then as x is approaching infinity, the function is going to be approaching infinity. All right, so you have the opposite of this situation for this one. You're going right here. So since you're going from infinity to negative infinity, what are you guaranteed to have? You're guaranteed to have at least one point or more where the function assumes a value of 0. Okay? So what does that tell us? That tells us that we have at least one real root. So the answer is option B. Okay? So let's go ahead and exhaust the possible cases. So if you have at least one real root, you have something like that. Let's go ahead and sketch it. So um, one real root is assuming that you don't have a term that's, causes you to go backwards. So it says has to go something like that. That's just one real root. Okay? And then the more terms you have, then the more roots you have, right? So let me show you the maximum um, maximum number of roots you can have. So let me show you that case. So this case right here, this is the least. Because it's an odd function, we have one real root. Now, you can do 2, 3, 4, all the way up to 7. Let me know. I don't want to, just to save time, let me show you what it looks like for 7 real roots. Um, Assuming a is greater than 0, you're going to have going from here 1, 2, 3, 4, 5, 6, 7. The maximum number of turns you can have, because the degree is 7 is 6. You can have more than 6 turns, okay? All right, so this is a case where you have 7 roots. This is the maximum number of roots you can have if your polynomial has a degree of 7, okay? But we don't know how many roots there is. So what we know for a certainty is that you cannot have anything less than 1, and you can have anything greater than 7. All right, so the correct answer here is option letter B. You guaranteed to have at least one real root because the degree is 7, which is odd. Okay, so we just keep that in mind.